Okay, in this video, we're going to take a look at identifying the vertex, focus, and directrix for each of the following. So we're going to start with part A, y equals 2 times the expression x plus 1 in parentheses squared. Now, we can get the vertex from the equation. This is also a plus 0 at the end. So our vertex would be the opposite, the h is whatever the opposite of the value paired up with the x in parentheses is, and then k is whatever else is added at the end. So our vertex would be negative 1, 0, which in this case, we can graph it as well. And here's our graph of 2 times x plus 1 in parentheses squared. And then notice our vertex also from the graph negative 1 and 0. Now for our focus point, we need to find the value of p, and for that we're going to use this value of a, this value of 2. So we set 1 over 4p equal to 2, multiply both sides by 4p to get rid of the fraction, we'll get 1 equals 8 times p, which then we can use p equals 1/8. Now in terms of finding the focus point, if we look at the graph of the parabola, the distance from our vertex to our focus point is going to be 1/8. And remembering that our focus point is always inside of our parabola, we're going to want to take this vertex at negative 1, 0, and we're going to want to add 1/8 to it. So if we add 1/8 to 0, we have our vertex at negative 1, 0. But then if we add that 1/8 to it, which I'm going to have to zoom in because it's really difficult to see. If we add 1/8 to it, we get that point negative 1, and then 0 plus 1/8 is 1/8. So our focus point is going to be negative 1 and then 1/8. Now for our directrix line, if we went up to get the focus point, if we added 1/8 to the y-coordinate of the vertex to get the focus point, we're going to subtract 1/8 from the y-coordinate of the vertex to get the directrix line. So once again, our vertex is at negative 1, 0. We want to go down 1/8 of a unit. So 0 minus 1/8, y equals 0 minus 1/8, is going to be our directrix line. And 0 minus 1/8 is y equals negative 1/8. So every point on this red graph, no matter what point it is the same distance away from this green focus point as it is from this purple directrix line. So part B, we have y equals negative 0.25 times x minus 3 in parentheses squared plus 4. Well, the equation, really simple to find the vertex, is at 3 and 4. So our vertex is at 3, 4. But again, there's nothing stopping us from graphing these as well. So if we wanted to graph it, it's going to look like, well, I'm going to have to zoom out a bit. And here is our vertex at 3, 4. Now our focus point, we have 1 over 4p equals, even though it's negative 0.25 or negative 1/4, I'm going to use it as a positive here because visually we're going to add and subtract the value of p to the y-coordinate of our vertex. So 1 over 4p equals 1/4, and we cross multiply and we get 4p equals 4, so p equals 1. Which means from our vertex, for our focus point, we're going to go down 1 unit so that our focus point is still inside of our parabola. So our vertex is at 3, 4. We want to go down 1 unit, so take 1 away from 4, and that's going to put our focus point at 3, 3. So our focus point is at 3, 3. And again, this has a length of 1 between 3, 4 and 3, 3. For our directrix line, if we went down 1 unit for the focus point, we want to go up 1 unit for the directrix line. And a horizontal line is going to be y equals, and in this case, y equals 5, because that's where it hits the y-axis. So here's our directrix line. So every point on this parabola, same distance from the focus point as it is from the directrix line. Alrighty, moving on. Part C, x equals 2 times y plus 7 squared minus 9. So here, our h and our k are switched. Our h value is negative 9, and our k value is negative 7. Now, again, we can graph this, so let's go ahead and graph it as well. Let me just get rid of these. And when we do that, when we graph that, notice that moving our graph downward, our vertex now is at negative 9, negative 7. So when we switch our x and our y, we also switch our h and our k. It's going to come into play later on in the next couple sections. So finding our focus point, we have 1 over 4p equals 2. In this case, a is 2. So multiply both sides by 4p, we get 1 equals 8p, so p is 1/8. So much like in example 1a. Now, because my parabola is opening to the right, I want to take that value of 1/8 and I'm going to add it to the x-coordinate. So for the point, if we do -9 plus 1/8, and then -7, well, a little bit tough to see. And let me change the color here. I'll go red. All right, and then zooming in, so it's easier to see. So here's our vertex at -9, -7. Going to the right 1/8 of a unit means we're going to add 1/8 to our x-coordinate of -9. And then -9 plus 1/8 gives us -71/8 and for x and -7 for y. Our directrix line, we're going to go the opposite way. So instead of adding 1/8 to go to the right, for the directrix line, we want to go to the left. So we want to do x equals -9 minus 1/8, which gives us -9 1/8 or -9.125, which if we convert it to an improper fraction is -73/8. All right, part D, x equals -3y squared. Just clear this out here. And for x equals -3y squared, the vertex should be at the origin. And there it is. So vertex is at the origin. To get our value of p, we'll set 1 over 4p equal to 3. Multiply both sides by 4p, and we get 1 equals 12p, so p is 1/12. So our focus point, remember, always inside of our parabola. For our focus point, we want to take this vertex, and we want to go 1/12 of a unit to the left, which means we want to start with our vertex at 0, 0. And if we're going 1/12 of a unit to the left, we want to subtract 1/12 from our x-coordinate of our vertex. So here's our focus point at, this is -1/12 and 0. So focus point, -1/12 and 0. Our directrix line, we want to go the opposite way. So if we're going to go to the right 1/12 of a unit from our vertex, for our directrix line, it's going to be x equals 0 plus 1/12. Which gives us this vertical line through 1/12 on the x-axis. So our directrix line is x equals 1/12. All right, that about does it for this video. Thanks for watching, and I'll see you next time.